This time, let's have our problem solving. Now, here is the problem. This is a sample of a work problem. Pen. Now, this is a sample of a work problem. And it's the same as the one that is in your workbook number 2. Now, a mason's helper, you know what's a mason? The one who's in the construction. A mason's helper requires 4 hours more to pave a concrete walk than it takes the mason. So you have 2 people here, the mason's helper and the mason. The 2 work together for 3 hours. Then the mason was called away. The helper continued to work and completed the job in 2 hours. How long would it take each to do the same job if they work separately? Let me draw first, okay? The stick man. Here's the mason. And here's the mason's helper. Now, can you tell me how long did the mason work? How long? In the chat box, how long did the mason work?
4 hours.
Okay, 4 hours. So, oh, wait first. Not that. The mason, the 2 worked together for 3 hours and the mason was called away. How long did the mason work? We don't know, right? Remember? We don't know how long did the mason work alone. So we just place X for the mason. And the mason's helper requires 4 hours more than the mason. So how long can the mason's helper work alone? That is X plus 4 or 4 plus X. Now, let's have the work table. We say represents and relates. We represent first. Now, who were the 2 people working? We have the mason. So what happened to my pen? And the helper. Now let's have this one. Rate. The formula is rate time equals work. Rate times time equals work. Now here, if it will take Ma'am Lil 10 hours to do a job, then what's my rate? My rate will be 1 over 10. Why? Because in 1 hour time, I only completed 1 over 10 or 1/10 of the work. Another, if it will take Juan to do the job for 3 hours, then the rate of Juan is 1 over 3. Okay? What happened to my pen? Now, let's have for the mason and for the helper. The mason will take X hours to complete the job by himself. So what's his rate in 1 hour? That's 1 over X. Next, the mason's helper needs 4 hours more than the mason. So his or her rate is 1 over X plus 4. Now the time tells us that if they work together or how long did it take them to complete the job. Here, the 2 worked together for 3 hours. Then the mason was called away. Then after 3 hours, the helper continued it and finished the job in another 2 hours. So it means that the mason only worked for 3 hours, while the helper worked for 5 hours. 3 plus 2. Ma'am, what if they really finished working together? Like example, Ma'am Lil and Pedro will work in cleaning the room. If we work together, we can finish cleaning the room in 7 hours. Then what will be my time and Pedro's time? So we write here in the time 7 and 7. If both of us work the same time. But in the problem, the mason helped first, then he left the helper, and the helper completed the work by himself. Next, in the third column, in the work column, we need to multiply rate and time. So, how to multiply fractions? Numerator by numerator, denominator by denominator. So you have 3 times 1, 3 over x. The other is 5 over x plus 4. Any questions? I'm still in the first step. Now let's go to the next step. The next step is the equation. Now, in the equation, here's how you will do it. In the equation, that's going to be work done by one plus work done by the other equals 1. Why equal to 1? It means that the work is completed. So equals 1. Now, you only place plus here if worker 1 and worker 2 are doing the same job or are helping each other. But if one is doing the job and one is not helping, like doing the opposite of this job, then we place minus here. Example, I think you have encountered the problem, the swimming pool with the pipe and the drain open, right? If the pipe and the pipe, if 2 pipes will work together, that's plus. But if the pipe and the drain are both open, they are not working together, right? The pipe fills, the drain empties. So it's minus. But here they are working together. So plus. Now, let's have, what's the work? What's the work done by the mason? Go back to your table. The mason, 3 over x. Oops, sorry. 3 over x. How about the worker, the helper? 5 over x plus 4 equals 1. That's now our equation. Let's go to our restriction. Ready? We write the equation on top. The equation is 3 over x plus 5 over x plus 4 equals 0. Not 0, equals 1. Okay. Let's have our restrictions. Denominator, please. First, x should never be equal to 0. Wait for a while. Baba. The next one. X plus 4 should never be equal to 0. So x should never be equal to negative 4. That's our restriction, okay? Next, let's have our Cram method. Let's have the quadratic equation. Let me write the equation again. Okay, now, so we have 3 over x plus 5 over x plus 4. I wrote it on the top and I'll write it again at the bottom. Now, multiply all by the LCD. I told you a while ago that the LCD can be the fraction, the denominators. So we multiply all by x times x plus 4. X times x plus 4. X times x plus 4. Okay. We cancel the x. We cancel the x plus 4. Again, when you cancel it in one factor, okay, don't cancel this one and this one. That's wrong. Both x plus 4 and x plus 4. So we're left with x plus 4 times 3 plus 5 times x equals this one. X times x plus 4. I'm sorry with my pen. Next, let's do the distributive property. 3x plus 12 plus 5x equals x squared plus 4x. Let's transfer all to the right side, okay? 3x plus 5x, that's 8, right? So once you'll transfer it, minus 8x. 12, transfer it, becomes negative 12. So, equals 0. So our quadratic equation now is x squared minus 4x, what happened to my pen, minus 12 equals 0. You just remember it. So in the roots, we have x squared minus, so next, 4 minus 4x, as the last, minus 12, right there, minus 12 equals 0. Now let's do the factoring. X, what are the factors? Minus 6 and x plus 2. So let's solve. X minus 6 equals 0. X equals 6. How about the other? X plus 2 equals 0. X equals negative 2. But remember, we are talking about time. So there's no negative 2 in time, right? So we just consider x equals 6. We cancel 2. So the final answer is x equals 6. But now, here's the next question. X equals 6 hours. But we're not yet done. In problem solving, you need to get back to your question. So what's the question? How long would it take each to do the same job if they work separately? We go back to our table. Ready? There. In the table, how long will the mason work alone? That's x hours, right? Our x is 6. So the mason can work for 6 hours. How about the helper? The helper can work for x plus 4. So that's 6 plus 4. So the helper will work for 10 hours alone, while the mason can work for 6 hours alone.